Hi, my dear students. In this video lecture, we are going to discuss about gradient, divergence, and curl. So, we are going to learn about del operator, gradient of scalar function, directional derivative, divergence of a vector, and curl of a vector. So now we discuss about the gradient of a scalar point function. First, we discuss about the del operator. Operator del is called a vector differential operator defined as del equals dou by dou x of I plus dou by dou y into j plus dou by dou z into k. So this is called the operator and also known as del operator. So del operator is used to work on scalar point functions as well as on vector point functions. Next, we discuss the gradient of a scalar point function. So if phi of xyz is a scalar point function of three variables and pi is differentiable, then the gradient of pi is defined as grade phi and also denoted as del phi, that is equal to dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k. So note that in the previously we said del is nothing but dou by dou x of y plus dou by dou y of j plus dou by dou z of k. Now this operator del is being operated on the scalar point function phi, and hence we have the del phi or grade phi is dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k. So where, as I have already told, phi is a scalar point function and del phi is a vector point function. So you see this, we see that here del phi is we are having the vectors I, j, k, and immediately we can conclude that it is a vector point function. So what is about the gradient? So magnitude of the gradient is defined as its magnitude is the maximum space rate of change of the function at the point of the gradient. Then what is the direction of the gradient? It points in the direction of that maximum space rate of change and known as the directional derivative in the direction. So here the gradient field. So what is the gradient field means? So now if you look at any surface and you take at any point, and if the surface is given by an equation like f of x is equal to some xy or xyz, it can be any number of independent variables. It can be 2 or 3 and in general n. So if it is going to be a surface and you are calculating the del phi, means it indicates it is nothing but the normal to the surface. Now we see that in this picture the direction is at each and every point it is acting towards the normal to the surface. So this is the direction of the gradient, because we have already told gradient is a vector, and therefore if you see the direction from this page or from this picture, it is clear how at each and every point the direction of the gradient holds. Next, we'll try to calculate a simple example on the gradient. Now here we are given a scalar point function x square yz cube plus xy square z square, and you have to determine the gradient of phi at that point p is equal to 132. So because we are discussing the variable in 3 dimension, we are calculating the gradient at the point 132. So we are given that pi, which is going to be the scalar point function. You see that here we don't observe any I, j, k or whatever it is. Therefore, it is not a vector function. It is a scalar function and it is given by x square yz cube plus xy square z square. Now, since there are three variables, we will have the partial derivatives here we are going to calculate. So, partially differentiating pi with respect to x, we get 2x yz cube. That is, we have to differentiate only x. The other, they remain the constant. Therefore, they remain as it is yz cubed. Plus, differentiation of x is 1. Therefore, y square z square and dou phi by dou y. So when I talk about dou phi by dou y, x and z are they are going to be the constants. They will remain as it is, and you have to differentiate y phi with respect to y. So therefore, here I will have differentiation of y is 1, therefore x square z cube plus in this case it will be 2y, so 2xyz square, and in a similar manner you differentiate with respect to z partially, we will get 3x square yz square plus 2xy square z. Therefore, the del phi is calculated as, according to the definition, dou phi by dou x into I plus dou phi by dou z into j plus dou phi by dou z into k. So substitute dou phi by dou x, dou phi by dou z, dou phi by dou y and dou phi by dou z. In this formula, we will get 2xyz cube plus y square z square into I. So that is for this. And similarly for dou phi by dou y, I have x square z cube plus 2xyz square into j plus for dou phi by dou z 3x square y square 3x square yz square plus 2xy square z k. Now we have to calculate what is the gradient at the point 132. So for x value you substitute 1 and for y value you substitute 3 and for z value you substitute 2. We will get what is called del phi at this point. So therefore, by substituting in this 2xyz cube plus y square z square, we are going to get 84, and in this you substitute the values for x, y, z. I am going to get 32, and the last one I am going to get 72. Therefore, the gradient is calculated for the given function at the point 132 is 84i plus 32j and plus 72k. Now some properties of gradient, they are given by if a and b are two scalars, then del of a plus or minus b equals del a plus del b, del ab equals a into del of b plus b into del of a. It is something like a differentiation of addition and subtraction and differentiation of product. So this is similar to the product rule in differentiation, and it is similar to addition and subtraction and differentiation. Next, directional derivative. Directional derivative of pi in the direction of a bar is given by d phi by dx equals a dot grade phi, where a bar is a unit vector given by dr by dr, modulus of dr. So any vector divided by its modulus is always calculated as unit vector, which is the unit vector in the direction of dr bar. So now we'll try to compute what is the directional derivative. So you are given the scalar point function x square z plus 2y square plus yz square, and we have to calculate at the point 1, 2, minus 1. In the direction of the vector a bar is given to be 2y plus 3j minus 4k. So now, according to the definition, we have the directional derivative in the direction of a is given as d phi by ds is equal to a bar dot grade phi. Now first we have to calculate what is grade phi, and then you take the dot product with a bar. we will get the required directional derivative. So as before we calculated grade phi, it is nothing but dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k, and a bar equals capital A by mod A bar. So pi is given to by this, and therefore the del phi is calculated, and it is given to be 2xz plus 2y square into I plus 4xy plus z square into j plus x square plus 2yz into k. This is the gradient for the given function x square z plus 2xy square plus yz square, which is going to be the scalar point function. Now you calculate at the point 1, 2, minus 1, the direction, the del phi becomes, you substitute here x, y, z, I will get 6i. In this component, you substitute for x, y, z, I am going to get 9, and then 9 into j, plus in this component, you substitute for x, y, z, I am going to get minus 3. Therefore, the gradient is calculated as 6i plus 9j minus 3k. Also we are given a bar equals 2i plus 3j minus 4k, and its modulus or magnitude is given as square root of the component of the coefficient of I, the coefficient of j, and the coefficient of k square. So I will get 2 square plus 3 square minus 4 whole square, and it is nothing but square root of 29. Therefore a bar is given to be a bar by mod a bar, and it is nothing but 2i plus 3j minus 4k divided by square root of 29. Therefore d pi by ds is equal to a bar dot grade phi. You take the dot product with this, I am going to get 51 by root 29. This is the directional derivative which is required according to the given problem. Next, physical interpretation of the gradient. One is given in terms of a graph of some function z is equal to f of xy, where f is a reasonable function, say with continuous first order partial derivatives. In this case, we can think of the graph as a surface whose points have variable heights over the xy plane. This is shown in the figure which is drawn in the adjacent. As illustration is given below, if we say place a marble at some point xy on this graph with zero initial force, its motion will trace out a path on the surface, and in fact it will choose the direction of the steepest descent. The direction of the steepest descent is given by the negative of the gradient of f. One takes the negative direction because of the height is decreasing rather than increasing. On the other hand, if it is going to be increasing, then the sign will be positive. Next, using the language of vector fields, we may restate this as follows. For the given function f of xy, gravitational force defines a vector field over the corresponding surface that is equal to f of xy, and the initial velocity of the object at a point xy is given by minus del of f of xy. The next point, the gradients is also describes the directions of the maximum change in other contexts. For example, if we think of f of as describing the temperature at a point x comma y, then the gradient gives the direction in which the temperature is increasing most rapidly. This is something about gradient. Now we talk about the divergence. So in vector calculus, divergence is a vector operator that measures the magnitude of a vector field's source or sink at a given point in terms of a signed scalar. More technically, the divergence represents the volume density of the outward flux of a vector field from an infinitesimal volume around a given point. So in physical terms, divergence means the divergence of a three-dimensional vector field is the extent to which the vector field flow behaves like a source or a sink at a given point. It is a local measure of its spread or outgoing extent. It gives the net flow of the vector field as a result of the exiting and entering flows. Next, the definition of divergence of a vector. If A bar is equal to AI plus AJ plus AK, then the divergence of A bar is defined as del dot A. So once again you see that del is an operator and A is the vector upon which del is being operated. Now here we are going to take A is a vector, del is a vector, therefore dot product is submissible. Therefore when you have the dot product, I will have dou A by dou X plus dou A by dou Y plus dou AZ by dou Z. So this is the divergence of the vector A bar. Now, this is an illustration how the divergence of a vector at a point P. So this is called the positive divergence, this is called the negative divergence, and this is zero divergence. For example, if you see this figure, all the trees growing, we can regard that as a positive divergence. And here this is positive charge, it is coming out, and when they are concentrated at one point you can regard that as a negative charge, and here it is going to be zero divergence. In this case it is going to be zero divergence. So these are some examples or instances where we can have the divergence. So now immediately look over the problem, how to calculate the divergence for a given vector point function. So remember here in divergence it is operated on vector point function. So given your a bar is equal to x square y into I minus xyz into j plus xyz square k, we have to find what is the divergence at the point 1, 2, 3. According to the definition, divergence A is nothing but del dot A. So this is the del and this is the A bar, and you take the dot product, and therefore it is nothing but I dot I is going to be 1, therefore it is dou A x by dou x plus, and the remaining components I dot j and I dot k will become 0, therefore you dot with j, again I will get dou ay by dou y, and similarly plus dou az by dou z. Okay, so this is what is called the divergence of a vector point function. Now you differentiate this with respect to x, I am going to get 2x. With respect to y, I am going to get xz, and for with respect to z, I am going to get yz. So when I take with respect to x, what I will get? It is 2xy, right? It is 2xy. In this component I am going to get y, means I am going to get xz. In this component you differentiate with respect to z, I am going to get 2yz. So therefore this is the divergence. Now we have to calculate the divergence at the point 1, 2, 3. So in the above equation you substitute for x, y, z 1, 2, 3, it will come around 13. So note that divergence is a scalar point. Next, lastly, we discuss about curl. So in vector calculus, the curl is a vector operator that describes the infinitesimal rotation of a three-dimensional vector field. At every point in that field, the curl of that point is represented by a vector. The attributes of this vector, normally length, direction, all those things, they are called the attributes, characterize the rotation at that point. The direction of the curl is the axis of rotation as determined by the right hand rule, and the magnitude of the curl is the magnitude of that rotation. Now, the definition of the curl goes like this. If A bar is equal to AI plus AJ plus AK, then the curl of A bar is defined by curl A equals del cross A. When you calculate the divergence, it is del dot A. When you calculate the curl, I am going to have del cross A. So since it is a cross product, always cross product of two vectors will give you a vector. Therefore, curl A is a vector quantity. So now del and then this is A, and this can be written as in the determinant notation Ijk dou by dou x, dou by dou y, dou by dou z, and the components of the given vector ax, ay, az. Now if you evaluate the determinant, you are going to get what is called the curl of a given vector point function. So example of a curl I can give as you see that here we can have the curl can be calculated at these instances. Next points to be noted regarding the curl. If curl f is equal to 0, then f is called an irrotational vector. So if you want to show a given vector is irrotational, you simply find the curl f and show that the value is going to be 0, then it is called irrotational. If f is irrotational, then always there exists a scalar point function pi such that f bar is equal to del phi, where pi is called the scalar potential of f. The work done in moving an object from point to P to Q is an irrotational field is given by pi of Q minus pi of P. The curl signifies the angular velocity or rotation of the body. Next, solenoidal and irrotational fields. Irrotational we have already discussed. Solenoidal means normally if the divergence reduces to 0, then we will call that kind of field as divergence. That is solenoidal. The null divergence is called solenoidal. The null divergence means what? Del dot phi is equal to 0, or therefore we say that it is solenoidal. If the divergence of a vector point function is 0, then we will call that as solenoidal. The divergence of the curl of any vector must be 0. So that is del dot of del cross A is always 0. Therefore we can say this field is irrotational. Divergence is going to be solenoidal because the divergence, this is a scalar vector point function, therefore divergence of the vector point function del cross A remains 0, then we call such a field as solenoidal, which shows that a solenoidal field can be expressed in terms of the curl of another vector field, or that curl field must be solenoidal field. The curl of the gradient of any scalar pi must be 0. This is a property once again, therefore immediately this can be shown, therefore del of del pi is equal to 0, which shows that an irrotational field can be expressed in terms of gradient of another scalar field, or a gradient field must be an irrotational field. Now lastly we discuss the example to illustrate the curl of a function. Now, given the vector a bar, you have to determine what is curl. So, we are given a bar and you have to calculate curl a. Now, here this is the ax, this is ay, this is az. So, according to the definition, del cross A is equal to I into dou I j k, dou by dou x, dou by dou y, dou by dou z. Therefore, these are the coefficients of the given vector, namely a bar. That is the coefficient of I, coefficient of j, and coefficient of k. Now you write I into dou by dou y of this minus x square yz minus dou by dou z of x square plus y square. So that is the first one. Next, minus j into dou by dou x of minus x square yz minus dou by dou z of y power 4 minus x square z square. So that simplifies to minus 2xyz minus 2x square z into j plus the last one dou by dou x of x square plus y square minus dou by dou y of y power 4 x square z square, that reduces to, when you differentiate with respect to x, 2x, and this is with respect to 4y cube into k. Now as before, you substitute for xyz 1 3 minus 2, you will get curl A is equal to 2i minus 8j minus 106k. So likewise, you can calculate the curl of a given vector point function. So thank you, my boys. So this is a small introduction on uh, gradient, divergence and curl. Thank you once again.